Good morning, everyone. Today we will be going through the first assignment of computer vision course. Uh, Coming to the first question, in the first question we were asked to calibrate the Oak Delight camera. So to first of all, in the code, I have imported all the necessary packages, and once this is done, I have created separate functions to calibrate each of the three cameras. So the two monochrome cameras and one RGB camera. These functions take 10 images of the checkerboard pattern. I have used in a 7 into 8 checkerboard pattern for this question. This also takes optional parameter delay, which in which you can mention the delay between each of the images that is being captured. Once the images are captured, I have written a separate function called as calibrate, which takes the array of images as an input and then tries to find out all the corners in the checkerboard. Once the corners have been found, it calculates the camera matrix, the distortion matrix, the rotational vectors, and the transmission vectors. All these matrices and vectors are stored in the respective folders of the camera we have used. And so we can see here that the functions that were declared earlier have been called. Um, and once the images have been taken, the array of images have been used to calibrate the respective cameras. We can see that all the important vectors are being stored in the file in the images, and you can see that all the important vectors are being stored in the respective files. So we have the camera matrix, distortion matrix, rotation, and translation. Moving to the second question. In the second question, we were asked to calculate the distance of a real world object with the help of an image. So first of all, I have imported all the necessary packages, and so over here I have imported all the vectors and matrices that we have calculated in the first question. First of all, I imported the rotational vector, the translation vector, and the camera matrix. Using these three, I have calculated the extrinsic matrix. And once we have the extrinsic matrix, we can now use the camera function. With the help of camera function, I was able to convert this image coordinate points into real world coordinate points. Now that we have the real world coordinate points, which are these, we can find out the distance between these two coordinate points with the help of Euclidean distance. And we can see that the distance between the two pixels in the real world is 16 centimeters. Moving to the third question. In third question, we were asked to see if it is feasible to get both an RGB stream and a depth map stream from the camera simultaneously. So we can indeed get a RGB stream and depth map stream simultaneously from the camera. For this reason, we have to create two pipelines, a pipeline just for the color camera and another pipeline for the monochromatic cameras. Then we need to write a small block of code that checks if each of this if each of these pipelines um, have any output. So in case they do, the image frame is being output onto the user's monitor. We are also asked to see if we can print out the frame rate that is being achieved by our camera. So I have also done this, and then we can observe that our camera can achieve up to 30 frames per second. Coming to the final question, in the final question, we were asked to run the camera calibration tool being provided by Depth AI. For this reason, I have downloaded the repository for Oak D Lite camera. So we have to change the branch and download the respective repository. Once we have done so, we have a file called as calibrate.py that has all the necessary code required for calibrating the camera. Once we run this file, we are asked to take the picture of our checkerboard pattern in several orientations. Once this process is done, we get a camera matrix, and on verifying, we can see that the camera matrix is almost similar to the camera matrix that we calculated in the first question. So that's the end of the first assignment. Thank you.